Greetings to all respected viewers. I, Ritik Raha of NSCC, am presenting a talk on medical image fusion using PCNN optimized by the WALE optimization algorithm. This is the International Conference for Convergence in Engineering 2020 and the paper ID is 178. Let us start with an overview of the contents we will be covering. As we all know, image fusion is an imperative operation in the field of image processing. PCNN, or pulse coupled neural network, a biologically inspired neural network derived from the neocortex of mammals, specifically cats and smaller mammals, was first proposed by Arpan et al., which made it perfect for image processing applications. However, the model thus proposed had 10 parameters and 8 variables and required expensive training. In view of these limitations, Wand and Ma proposed a simplified PCNN. It still had all the parameters that determined the quality of fusion. However, the number of parameters that were required to tune was lessened by a considerable degree. These parameters can only be mechanically calculated through expensive and time-consuming training. The approximation of m-PCNN parameters suited to the task of medical image fusion has been readily identified as an optimization problem. To this effect, we propose the use of WOA-PCNN, where the modified PCNN is optimized using WALE optimization algorithm and employed to the task of image fusion. Here we have the diagram of the simplified m-PCNN model as proposed by Wand and Ma. So Fij and Lij are the feeding and linking synapses corresponding to the original ith and jth position of the pixel in the original image. Sij refers to the external stimulus and determines the time of ignition. Wijkl represents the local connection matrices comprising of weights that can quantify the influence of each neuron in the vicinity of the central neuron. Beta is the linking coefficient and Yij is the binary output of the model. Alpha theta is the attenuation time constant and V theta is the corresponding inherent voltage potential. Moving on, we have here the governing equations for m-PCNN model. Now, the WALE optimization algorithm, WOA, which mimics the social behavior of humpback whales, was inspired by the bubble net hunting strategy of whales as shown in the diagram. This nature-inspired algorithm was originally tested by 29 test functions and 6 structural design problems and seen to outperform other well-known optimization algorithms such as genetic algorithm, particle swarm optimization, and quantum particle swarm optimization. Now we have the governing equations for the WOA model. Dist, the variable dist, indicates the distance from the prey to the whale. Xpos is the position of the individual whale. Xpos star is the best possible position obtained so far. Capital A and C and small a are coefficient vectors useful in the process of determining or shaping the governing equations. The behavior of humpback whales can thus be described or modeled by two methods. The first of which is this one, the shrinking encircling model, where we vary the parameter capital A, factor capital A within set bounds of the parameter small a. The second method is the spiral updating position model, which simulates the helical pattern. Here, P is a variable randomly chosen between 1 and 0 and is useful for determining a switching between either shrinking encircling model or spiral updating position. Apart from the bubble net strategy, the humpback whales also search for prey randomly as shown in the following set of equations. Ultimately, the WOA algorithm is terminated when the criteria is reached. Speaking of criteria, The fitness criteria is the objective function which is required by the optimization algorithm to search for the hyperparameters. Now the objective function in this case has been chosen as the maximum of the numerical sum of spatial frequency, image entropy, average gradient, and edge count. Image entropy is the measure of information within an image. The average gradient is the measure of image sharpness and gives a measure of texture present in the image. The degree of activity in the image space is expressed by the spatial frequency, and edge count is the clarity of edges preserved after fusion. Here we have the entire model used for the fusion of medical images. The two original images are first passed through the WOA algorithm, which uses the fitness criteria to calculate the parameters for both of these images, which are required by the PCNN algorithm. The PCNN algorithm then calculates the feature maps of these two images and passes them on to the decision box. The decision box then allows the fusion of these two images as per the information in the feature maps. We have the algorithm used by the WOA optimizer according to the respective equations as shown previously. The primary algorithm for calculating the feature map and performing fusion is also shown here. The source images or the original images are 5 groups of 256 gray level images of CT and MR imaging. These are the fusion results from the proposed method as well as some other credit-worthy methods against which the comparison has been drawn in this work. We have here a table comparing the proposed method with other well-known image fusion algorithms such as QPSO-PCNN, discrete cosine transform, Laplacian, dual tree complex wavelet transform, and also principal component analysis. We see that the proposed method, which is WOA-PCNN, outperforms many of the above methods with considerable leeway on all accounts. In wrapping things up, we see that the proposed method, when put to test with other well-known image fusion algorithms, readily outperforms them all. The optimization process, which is of key importance here, is using the WOA, which is effortless considering no previous setting of parameter or training for reaching the global maxima. In the future scope of the research, we would like to extend the algorithm to other areas of image processing beyond fusion and even apply it to other modality of images. We have here some of the references that we have used in this field of work. Finally, I would like to thank IEEE and NSSC for organizing this conference and the viewers for listening in. My co-author Arpan Sengupta and above all our project guide Dr. Supriya Dhabal, without whose guidance this would not have been possible. And now if we have any questions.